Welcome back. One of the things that I wanted to do here is just a few more examples for those people who were not entirely following along on my last video. And I also wanted to talk a little bit more about another reason that this is useful, which is a valid question considering that if we have a calculator, we can do all this stuff very easily. You might wonder, if I have a calculator, why do I care about this at all? And I'll talk about that here at the end. I won't go into a lot of detail, but I'll talk about it at the end. Let's start with this one right here. I've got the function 3x to the third minus 9x squared plus 10. And I want to figure out what value this takes on when x is equal to 2. In other words, I want to find out what f of 2 is. So to start with, I'll write down my coefficients. Now notice, I don't have a term here that's just an x term. I've got an x squared term and a constant term, but nothing in between. And I didn't say this explicitly last time, but I hope that it's pretty clear that to do these kind of problems, you really do need to have your polynomial function written in standard form, right? Starting with the highest order term, the x to the third term in this case, and working your way down to the constant term. That unless you have them in that order, this is going to give you all kinds of wrong results. So let's start here. 3, -9, 0, 10, right? That 0 is there for that missing x term. And last time I was writing this up here, but it doesn't really make a difference. So let's see, we drop down the 3, and now we multiply and add, multiply and add, multiply and add. So 2 times 3 is 6, -9 plus 6 is -3. 2 times -3 is -6. 0 plus -6 is -6. 2 times -6 is -12. 10 plus -12 is -2. So according to this synthetic substitution method, f of 2 is equal to -2. So that was pretty straightforward. If I had had these in the wrong order, actually, let's assume that we understand that, but let's say that I missed that fact that there was supposed to be a 0 here. Let's say that I did this. I'm going to do this in a different color so we can kind of see that it's not right. Let's say that I accidentally wrote 3, -9, 10, evaluated at 2, drop down the 3. 3 times 2 is 6. -9 plus 6 is -3. -3 times 2 is -6, and 10 minus 6 is 4, which is not correct. If I plug 2 into my original expression, that doesn't come out to 4, right? So the problem here is we skipped that 0. Got to have that 0 there for that missing term or it doesn't work. Let's go ahead and do another example. I'm going to skip down here to this example right here. I've got f of x equals 2x to the third plus 17x squared plus 7x minus 95. And the question is, what is the value of this when x is -7? What is f of -7? So once again, 2, 17, 7, -95. Evaluating this at -7. Drop down the 2. And again, we multiply and then we add down. Multiply and then add straight down. Multiply and add down. -7 times 2 is -14. 17 minus 14 is 3. 3 times -7 is -21. 7 plus -21 is -14. negative 7 times negative 14 is positive 98, and negative 95 plus 98 is 3. So apparently f of negative 7 is 3. And again, we could evaluate this ourselves, right? We could plug negative 7 in for x. We should get the exact same answer. But the point is, this is faster. Now, again, it's perfectly valid. It's perfectly valid to ask, why am I doing this, right? Given that I could just pull out my calculator and say, what's 2 times negative 7 to the third plus 17 times negative 7 squared plus 7 times negative 7 minus 95. And I would get 3. Same answer. Hey, how do you like that? Well, that's true. And I'm not here to tell you that you shouldn't use a calculator for this stuff. And I'm not here to tell you that you're not going to have a calculator available to you. That's completely up to your teacher whether you're allowed to use a calculator. For my students, they're allowed to use them. And on top of which, I'm not going to tell you that you're not going to have a calculator with you, because most of us carry a phone around with us that has a calculator on it. But there's something else actually going on here that we're not going to get to until later in the course. This process is actually telling us a lot more than just what the value of f of negative 7 is. There's actually something else going on here. And later on, we'll talk about synthetic division, which is this exact same process, but used for a slightly different purpose. And when we talk about that, you'll begin to see why this is actually a valuable practice. Why knowing how to evaluate f of negative 7 using this method is more useful than just saying that f of negative 7 is 3. All right, one more example, and then we'll wrap this up. Here we go. I've got 2x to the third minus 4x squared plus 7 halves x plus 1/3. And I want to find f of 1/2. So here we go. 2, negative 4, 7 over 2, 1 over 3. And I want to find f of 1/2. Right, once again, I drop down my 2. 2 times 1/2 is 1. Negative 4 plus 1 is negative 3. 1/2 times negative 3 is negative 3 over 2. 7 halves minus 3 halves is 4 halves, which is just 2. 1/2 times 2 is 1. And 1/3 plus 1 is 1/3 plus 3/3. So it's either 1 1/3 or it's 4/3, depending on which way you prefer to write it. So f of 1/2 here is 4/3. This does, by the way, point out one potential weakness in using a calculator for this. Depending on the model of calculator you have, it may or may not be able to do arithmetic with actual fractions. If your calculator uses just decimals, if you have to put 1/3 in your calculator by literally doing 1 divided by 3 and getting 0 point lots of 3s, then there's a chance you might get an answer that's slightly off at the end, because your calculator does have to round when it runs out of space for digits in memory. Now, most of the time, calculators will actually not display all of the digits they have calculated, so they can actually do some rounding and make it look pretty accurate. But that's a whole other topic as to the differences between decimals and fractions and which one's better and which one's more useful. That's a whole other topic, which we're not going to get into. The point is, if I do things with fractions, I get an exact result. F of 1/2 is exactly 4/3 here. And again, in a later section, we'll talk about why what I've done here is more useful than just figuring out what f of 1/2 is. When we get to synthetic division, we'll talk about that. So hopefully these extra examples have been clear. Make sure to look for missing terms, missing air quotes, terms, when you when you put these coefficients down, like we had in that first one, we had that missing x term, so we put a 0 down. If you don't do that, you're going to get wrong results. And obviously make sure that these are in descending order, that this is written in standard form, right? Highest order term first. All right, thank you very much.